All right, so we're recording. So hi, everyone. Thanks for joining us for the online meetup on the GraphXR Epidemic Simulator. I'm Corrine, the community manager at Neo, and this is Alex. Hi, Alex.
Hi.
Do you want to tell people who you are?
Yes, I'm the communications coordinator at Kinniviz. Sorry, it's the morning.
Yeah, Kinniviz is the parent, like the parent who creates the GraphXR product. Has everyone here, has anyone used GraphXR? You know, just a chat, yes or no. And we also have on the call, we have Robert, Allison. You can't see his video because he doesn't have the video thing set up. Okay, so Sony's used it. We have some no's, so this is going to be fun. And some yes. Robert, do you want to introduce yourself, and then you can share your screen, and then we can let you just take it away.
Sure, yes. So my name's Robert Allison. I'm Director of Products at Kinniviz. I've been with Kinniviz about 6 months now, and I'm working to make GraphXR into a great, but even better product than it is already. For today, for this presentation, I'm hoping to show some of the possibilities with GraphXR, and particularly for an epidemic simulator, which of course under the present circumstances is very topical. I will walk you through a sort of a demonstration. Please interrupt and ask questions.
We love interruptions.
Yeah, and I'll try and deal with them. So should I go ahead?
Yeah, if you have, so for the attendees, if you guys have any questions, you can post them directly in the chat. And Sony and Wei are also here. So they can either answer the question in the chat if it's something quick, or Sony and Wei, is it okay if I give it up to you guys to ask the questions if you're going to interrupt Robert in the middle of his presentation on whether it's something that we should save for the Q&A or if we should ask later? Is that okay? Cool. So Sony and Wei, your microphones are enabled, so you're able to just turn your microphone on and just ask away. So yeah, do you want to share your screen, Robert, so we'll shut off?
Right, let's do it. Okay, I hope you can see screen.
Yes.
Yep. So this what you should be seeing now is the projects page. There's a landing page for GraphXR. So the first thing we're going to do is we're going to create a project, and we're going to connect it to our Neo4j data source. I'm running Neo4j in a single database sort of mode. So let's create a project. And we're going to call it Epidemic. So we're going to configure our Neo4j instance. It's localhost. And we're going to talk directly to it from the browser, because GraphXR is a tool that lives in the browser mostly. So we're going to go directly to Neo4j from the browser. Now, I do have to allow that, so that's fine. And I should be able to proceed. Okay. So open the project. And we're going to query our database. Now the data is some sort of realistic social graph data that isn't real, shall we say. So it's pretend real data, which is handy for this particular scenario, because we want something that's representative of how people are actually connected together. So we're going to just put in all the data, nothing fancy in our Cypher query. Give it a few moments. So this data, what we're particularly interested in is how people are connected to other people. And because we're going to use those connections as a basis for our simulation, The intuition is simply that if you're connected to an infected person, there's a probability that you will also get infected. And so it's that simple. But to sort of make this meaningful, we do need a realistic set of data, which is being loaded right now. Just check that we're doing okay. Okay. Yes, here we go. So it is rather a lot of data, so it has taken us a little while to bring it all into the graph space. And as you should be able to see in front of you is a big ball of social graph. We have like about 5,000 nodes, proportion of organizations and a proportion of people. So we can use GraphXR to highlight the people and indeed the organizations and the relationships we have between them. So we have work at and study at. And so we sort of have a big ball of social connections, which is perfect for what we're trying to simulate.
How big is this data set, Robert?
So this is actually a portion of a much larger data set, but we've got 5,000 nodes at the moment currently in the graph space. So now what I've done extra to this data to ready it for the simulation is I've actually seeded one of the individuals here. So and to do that, I've simply added a seed property to a particular node, which I'm hoping we should be able to fly into. And so you can see this is our seed node, our patient 0. And that's what the simulator is going to pick up on and use to initialize itself, and it's going to be where it's going to start. So let's have a look at the simulator. Now I'm going to pull up the simulator. The simulator itself is an experimental piece of code, and in GraphXR we have a special way for developers internally to open such pieces of code. So this is kind of useful because it allows us to add extra tools, experiment with extra tools for clients or for other reasons, and prototype them within GraphXR. Hang on, I might have spelled something wrong here. Yes, I did. Obviously, there are some downsides to this particular technique, and in fact, we are working on a much more convenient way to launch such special tools. And this tool is written in React, so it's sort of the nice sort of React goodnesses that we can then use in the user interface for the tool. So I'm going to sort of put that on the top there. And I'm going to close this query window. So I'm going to explain a little bit about the controls of this simulator. The duration is the duration of infection. We're kind of imagining that each cycle is a day. So we're saying that the duration, or the infectious duration, shall we say, is 10 days in this case. The probability is during each day, what probability an infected person has of infecting a connection to them. And the iteration rate is the number of days per second, if you like, that we're going to run our simulation at. So I'm going to initialize the simulation. And I'm going to look at this infection property. And the infection property, we're using 0 for uninfected, but could be infected, or vulnerable, shall we say. 1 for infected, so we so far have just 1 patient that is infected, our initial seed, and 2 for recovered, because after the 10 days of the infection, we're going to assume the patient recovers and, importantly, is no longer infectious. So I'm going to disable force layout here just to make things a little bit calmer. And I'm going to start playing the simulation. As you can see, firstly, yes, the graph. So in the graph, you'll see red bars, and they are the new cases each day. So to begin with, we have just 1 new case. And then you'll see blue bars appearing, which are the cumulative cases. This is probably very similar to charts you might see on worldometer and so forth, where you have the daily and the cumulative. So let's play and see. Hopefully this will work. Okay, I'm going to pause here. I'm going to pause, and we're going to have a look at these first few days of infection. And you can see on the graph that we have gone from our patient 0, and we've got some extra cases. But we can also look at this in GraphXR if we use this property 1, meaning infected. So we can actually now see, and we can zoom in, so we can see using GraphXR like exactly what's going on, and how our patient 0 has infected other patients, and so on, as the simulation progresses. So let's continue. I think, as you can see, there's the orange dots are appearing more and more. Again, we can pause and see what the situation is. Yeah, so that's we got a big cluster occurring there, as these people are very connected through work or school or so forth, and we've actually spread to a subcluster over here. Let's continue, and we're seeing a geometric increase in cases, but then it seems to go to linear. And I think this is a reflection of the fact that we actually have a quite small data set here. So we're sort of already, even in these early days, we are already reaching the sort of the limits of our population in some sense. So again, I've paused it at day 29, I think it is. And we can see that already we are widespread through our population. So it may be that we're essentially running out of connections to, if in fact, or at least the progression is now more linear. So I'm going to, we can also see, actually now we can actually see some recovery starting. So our initial sort of infections have started to recover. So there's sort of like some herd immunity, if you like, is sort of growing there. Let's continue.
We do have a couple questions.
Sure. Yeah. Let's.
Do you want to wait until you're going through? Okay.
Take questions now. Okay. So yep. Go on.
I mean, yeah. So we have so George Chambers. I mean, Sony kind of answered this, but he asked if this data set has a geographic component that you're going to be reviewing. Probably not, right? This data set doesn't have it.
No, this particular data set, or this subset of the data set, I don't think has a geographic component. That's not something that I looked into.
Okay.
I mean, it's the connections is what I was particularly interested in. But of course, it would have a geographic component, and in real data, it would have a geographic component. So yes, so then you'd be able to see it's going through the country, shall we say?
Yeah. And I'm wondering, because I don't want to keep interrupting you in the middle of your presentation. So like, I don't want to like bring up every question that comes up. So I'm just going to say really quick to attendees, if you have a question that you want to wait till Q&A, just put it in the Q&A section. There's like a little tab for it in the chat. And if you want questions asked now, you could ask them now. I'm gonna let you continue, and if there's other questions that come up in the middle of the chat, in this chat section, I'll ask them. But if not, we can wait till the Q&A, because I just want you to be able to get through stuff, and I don't want to ask questions that you're getting to, you know.
Sure, no worries.
So, okay, thanks.
So let's continue running the simulation, and it runs to the bitter end. It runs until there's nobody left to infect, and all the infected people have recovered. So you can see we sort of rise up, and then as we saturate our population, we start to tail off and reach the end of the simulation. Now, as this simulation is progressing, it is actually recording the sort of the metrics that you see in the graph, so total cases, but also recoveries and so on and so forth. And so once the simulation has come to its conclusion, these figures are actually downloaded. It's probably a good time now, if anybody has any questions that they want to ask, any further questions, while we just wait for this to come to its end.
If anybody has any questions now that you want to ask, you could push the little hand raise thing, and then I'll give you a second to answer. There's a little hand raise icon next to the smiley face emoji. Okay. All right. So yeah, we can continue. We could save anything for the Q&A tab at the end.
Sure. Okay, that's great. So as you can see here, the GraphXR is updating these numbers, and so we can even see where we got just the last few cases to go, and so we expect the simulation to be finished pretty shortly. We can also notice that some components of our population, not those, that's the recovered, but some components of the population were never infected because they were not actually connected to our graph. So just a few more moments. Okay, so the simulation is complete, and we've downloaded our metrics as a CSV file. Now, this is interesting, and we can also see how our cumulative curve has followed the sort of sigmoidal picture pattern, which is similar to what we might see in a real disease progression or epidemic progression in a population. But now what I'd like to do for the final part of the demo is demonstrate how we can change our lockdown strategies. And this is something that is, of course, of crucial importance at the moment, is when to lock down, when to release lockdown, etc., etc. Now, I'm not going to say that this simulation is at all predictive or should be used to inform that kind of decision, but we can certainly see what effect doing a lockdown has. So let's reinitialize. Back to where we started from with our single case patient 0. And we're going to keep the same probability for the first, let's say, maybe 10 days or so, something like that. So you've got a nice bit of exponential growth going on. Okay, so the public authorities have been triggered. So let's pause the simulation there. And let's change that probability. So now we're reducing the probability by an order of magnitude. So now effectively everyone is locked up at home and we can continue the simulation. And as you can see, our new cases have been completely crushed. This is very good news. We're beating this epidemic. But let's say now we get a little bit confident and we think it's over. Let's return everything back to how it was. Continue playing. And we hope. Oh, we might have beaten it this time. Okay, so it looks like that lockdown actually worked, which is good news. Let's try it again. So, case. We're going to pause after 10 days or there around. Go into a lockdown. Continue on. Crush the infection, but this time we're going to release the lockdown a bit earlier. Let's see what happens. So now suddenly we have a jump in cases, more, and we're back to geometrical or close to a growth again. And so you can see in this scenario where we didn't hold down our lockdown for long enough, everyone gets infected again. And of course you can pause and we can introduce another lockdown and play again to see what effect that has. And then release the lockdown. A sort of hammer and dance, I think, is the technical term here. We'll see what happens now. And okay, yeah, so we're back to exponential again. So I'm not going to say that this simulation can give you quantitative results, although if the underlying social graph was accurate or representative to some extent, then there may be able to get some sort of numerical predictions out of it. But as much as anything, is probably about a qualitative sense of what happens in an epidemic. And what's nice about this simulation is it's actually operating as the disease operates. So there's no statistical magic going on in the background. There's no statistical assumptions as such. You have a graph, you have people connected on the graph, and then you are running a Monte Carlo simulation to propagate this epidemic through that population. So I welcome any questions you might have.
So we have some questions in the Q&A. I don't know, Robert, are you still here by chance? Let me see if he's still here. Not you, Robert Allison, different Robert. I think he stepped away. So, all right, in the Q&A, we have a couple questions for Cesar. Do you, I could just read them off to you. So one of the questions is Cipher Query is a proprietary interrogation language. Statement question. He said, do you map super spreaders as very connected nodes? And would super spreaders then be at the center of the blob? And does everything run in browser? You can answer them as we go if you want to.
Yeah, sure. Okay, so let's take this one at a time. So your first question about super spreaders and this sort of thing. Now, the blobs you see in this graph are actually they are they naturally arise due to the connectedness of these nodes. So essentially, nodes that are very connected, so therefore people that are very connected, will sort of clump together because it's a force. It uses a force layout. So nodes that are tightly, or nodes that have many connections, are drawn towards other nodes that have many connections in common. So, which is quite nice because then what might be just a plain set of data in your database, when using GraphXR, you can actually see the clumpiness and get some sort of qualitative understanding of your data. So in this example, we can see we have a number of super clumps, shall we say. So it's
super clumps.
Sorry,
go ahead, I'm sorry.
So it's not so much about super spreaders in this simulation as clumps. So schools or workplaces where lots of people work at, or lots of people know each other, and so
communities.
Yes, communities. That's right. And so it will spread very rapidly through those communities. Now, of course, if you do have a person who has many connections, then they will act as a super spreader. So yeah, that's in fact something we can sort of interrogate the graph for. And so,
okay.
What's the next question on that?
I am going to I'm going to mix it up because there's a bunch of questions actually that came in. So I'm going to mix it up because Cesar has a bunch of questions, and then there's also Mark and Daniel also came in. So I'm just going to mix it up. Mark Hutchinson said, is there a way to determine the introvert extrovert status of people and tweak their individual spread rate?
This is something that could be added to the simulator. At the moment, people are just considered to be a person is a person, you see what I mean? There's no differentiation between them apart from who they're connected to. So, but you could enhance the simulation by adding properties to people, saying the degree of social interaction they have, which of course influences the probability of them passing it on to somebody else. So yeah, next question.
Doesn't the fact? Oh, by the way, so if he answered your question completely, or if you have any follow-up questions, you could just ask. By the way, doesn't the fact that about one fifth appeared to be unconnected give reason to question the accuracy of the underlying social graph, as certainly 1/5 of the population are not unconnected to the other members of the population?
Absolutely, I think that's a fair comment. I would say that this is actually a portion of a much larger social graph, and it's possible that in my attempt to put together or trap a portion of that data set, which is a reasonable size to run this simulation, which after all is an experimental simulation. If we wanted to make a real simulation, we would scale up to something more like the population size of a city, which would require a lot more number crunching, shall we say. So yes, you're right in that perception.
Okay, and also we have, can you run a split screen comparative visualization of simulation 1 and simulation 2?
Not in GraphXR. It sounds like a nice idea. I suppose I could have population 1 and population 2 and configure two simulations, one that was looking at population 1, one was looking at population 2. So yes, this is something we can do, but I can't do that right now, if you see what I mean.
Okay. And also, let's see. Sorry, one second. Okay, so internationalization, and localization.
Right.
Is there any kind of support in Neo4j Desktop, Bloom, and GraphXR?
That's for GraphXR as a whole. I'm sure Wei will correct me if I'm wrong, but my understanding is that at this present moment we are not internationalizing GraphXR. It's something that, of course, we should be doing.
Mm-hmm. Okay. And does everything run in the browser?
Yes, it does. So GraphXR is a browser-based. Yes, it runs. This simulation is running in the browser. GraphXR is running in the browser. When you connect to our servers, our servers will store your configuration and allow you to store project data if you want, so views on your graph. But your actual data will be stored in Neo4j. So GraphXR should be seen as like a visualization front end to Neo4j. So you basically bring data from your Neo4j database, a portion of that into your browser, and then you can view it, manipulate it, run simulations using it, and then choose to save it back to Neo4j should you wish to.
Okay. And then Cesar was asking about the query language. The query. He said, is it a proprietary query? And how is the documentation on it?
Right, so the Cypher query language, right? This is what we mean. That's a Neo4j query language. Which, as my understanding, is the Neo4j is an open source project.
Yes, that is correct.
Yes. My understanding is also the documentation is very good. I think certainly I found Cypher documentation to be good.
Yeah, it's open Cypher. Mark just put it there. So okay, I'm just being the messenger.
Yeah, new words.
All right. Does anybody else have any questions? For Robert? That was probably the most questions we've ever had for an online meetup. The questions are good.
Yes, yeah, very happy to have them.
Yeah, a lot of times people have thoughts in their mind, don't ask questions. So, Alex, do you have any questions? I know you're a questions person. All right. Yeah, if anybody has any questions and you need to take time to write it out, you can always put the hand raise icon, and then we can give you time to ask the question. Okay. Mark said he's a questions savant, but he's good now, so it's good. Is there something else that you wanted to review, Robert, or?
No, I think I'm just running this simulation again just to show you. But no, I think that's I think I've shown what I can show on this.
Cool. No, this is great.
Just one last thing I will add is I didn't talk about it here, but the duration and the probability, you can actually use like a file to drive these. So depending on the iteration number, you can sort of define a lockdown policy or strategy in a file, and then load up the file, and then it'll automatically change these numbers. But for simplicity's sake, I sort of left that out of this demonstration. But just to know that you can drive this with a file.
That's awesome. This is very, very interesting. Thank you for taking the time and sharing it with everyone.
That's my pleasure.
Cool. So if nobody else has any other questions, oh, wait, we have one. What is the largest data setup can run a query like this on? Right.
So in terms, the two things here, one is your database that you're querying from, which can be as large as your sort of Neo4j installation can cope with. And then obviously you query a portion of that data. So in this particular example, I actually brought in the whole data set just for ease of use. But more normally, I would have a much larger data set, and I'd be bringing in a portion of that into GraphXR. So we're always working to make GraphXR more memory efficient and faster, etc., etc. This is running 5,000 nodes and something like so we got like 10,000 connections here, or edges. So 5,000 nodes, 10,000 edges. And GraphXR is working fine now. I mean, it runs on the browser, so it depends on your particular system. My system is struggling a little bit because, of course, running the webinar, and I'm also running Neo4j locally and these sorts of things. So I'm kind of getting to sort of to the edge of perhaps where to be feeling comfortable with this. But because it runs in the browser, it sort of will depend on how much memory your browser you can give to, if you see what I mean.
Okay. And then Ed asked, have you analyzed any graph analytics like centrality, et cetera, while the simulation is running?
Oh, that's an interesting one. No, I haven't, but we do have such tools in GraphXR. Indeed. So, for example, these tools. So, and yeah, so I could. It would be interesting. It would be interesting to run them while the simulation was running. So yeah, that's something I'd be interested in following up.
Okay. Alex asked, how could we potentially show recovered cases by itself to show herd immunity?
Okay, so if we initialize, now this is something, there's several elements to this. One is we can, just run the simulation again, we can show the recovered cases as they appear on the chart. But then the other thing that we could do is that, whereas I've just started as a single patient 0 as the seed case, patient 0 was infected, but I could equally pre-populate the graph with perhaps 50, 60, 70% recovered people, or indeed I could run this simulation partway through, pause it, take those cases as being herd immunity, the recovered cases, and then rerun the simulation and see what goes on. So there is certainly some possibilities with looking at. So here we are looking at the recovered cases, and we can use those as maybe as an input to another simulation.
Mm-hmm. So, you know, I'm interested too if people would have like interest in like potentially doing some kind of like hands-on workshop-y type thing on this kind of problem data set. Would anybody have interest in that? If they have, you could just say yes or no in the chat. So we do have some interest in it. I think that so Peter asks, how did you generate the original graph, and is it real data? Like I said,
sure, right. Yes. It's not real data, it's pretend real data. And we were using it for a different project. So it's kind of been borrowed from a different project we were working on, if that makes sense. So I wouldn't wish to present it as necessarily statistically meaningful. It's representative, but I mean, if I was going to do this simulation in a formal sense, for some sort of produce some formal results, I would firstly try to use a much larger data set, and secondly make sure that I had a data set which had been curated in a sort of sensible way. Whereas in this case, I just needed some data that was representative of a population.
Mm-hmm. I'm thinking about like somebody who was asking about the spatial or geographic location stuff. I don't remember where the question came from initially, but if anybody is interested in that kind of stuff using GraphXR, there is some like content on YouTube about it.
Yeah.
And also, this is the most questions we've ever had for any online meetup ever, which I love. I don't mind it, but the simulation model, the script that you are running, would you write it Neo4j as well, in Neo4j as well, I guess?
So the simulation itself is just written in JavaScript, and it doesn't run any database operations. It doesn't bring any data itself into the graph space. So you're setting up the simulation sort of manually using Cypher queries manually. Let's say, and then if you are sort of parameterizing the simulation using a sort of a lockdown type file to drive the simulation, then again, that's just JavaScript, which is picking out that file and changing properties of the simulation itself, not so much the properties of the graph. But I mean, that's something that could be looked at, is actually altering the graph as the simulation progressed. But at this stage, I was kind of sort of made sense to keep the graph stable, and then just run the simulation through those nodes. I hope that answers the question.
Cool. Yes, thank you. All right, cool. Anybody else have other questions? Oh, Sony joined us. Hi, Sony. Hey, where'd you go? Sony popped in for a second. Just see him. It's funny. Oh, Sony, I can't hear you. No. Now we can hear you. Oh, now we can't. Now we can't. Now
sorry.
we can.
Didn't mean to interrupt. I do have something to say at the end.
Yeah, say, please.
Okay. Well, I just wanted to add, and thank you, Robert. This is we're very excited about this, simulation project, which is a very interesting experiment. We also are working right now with a couple of organizations on a contact tracing solution. So we're now expanding that. It's basically for organizations that are trying to protect their teams internally, and doing so without necessarily needing app or device information to do the contact tracing, but just sort of using practical available data. So I'm just going to put a link to that here in the chat. So yeah, anyone who's interested, please check that out. So
How do I contact Sony Green? You can message him on the Neo4j community site. You can message him on the Slack.
I have no idea how to reach me.
You could also email him. Alex is also here too. She's kind of been a great liaison. There he is. There's the email. Well, Alice is asking about what other kind of visualizations that GraphXR can do. So I think it's more like capabilities of like what kind of things you can actually do with the visualizations. There's some really good content online, but I'll let you take it. Sonny.
Oh, well, I guess just one thing. I know that there was a question about geospatial. So we do have, mapping, as well as doing time series and both sort of a playback like what you're seeing here in the simulation or as a timeline. What's really cool as well that we, I don't know if we have any really good demos of available, but being able to look at 3D objects with a graph data model. So if you were to imagine, being able to see sort of a voxel-based visualization of a location or anatomy or something else, but applying the label property graph. So yeah, there's a lot of cool stuff you can do with it.
Cool. I'm glad you jumped on. I feel so weird without like the Robin here with his presenter screen. It's just like me. I'm just like, all right. All right, cool. So is there any like resources or anything you want to share with anyone while we're here too?
Well, so there's the link to the contact tracing. I guess also just for anyone who's interested in trying out GraphXR. Well, first off, that there's a free version of GraphXR that anyone who wants to try can sign up and start using right away.
Cool.
Yeah.
Put that down here. And for those who are interested in learning, we also have a learning page, how to GraphXR. So link to that as well. Yeah, I think that's it for me. Sorry to jump in on you, Rob. Anything else you want to?
No, that's great. I'm just trying to put up some of these pages for you while I have the screen. Yeah, so we do have, as you can see here, this is our learning landing page, and we have some great videos on how to use GraphXR and its capabilities, and how I think it allows you to not only visualize your data that's in a database in a sort of three-dimensional manner, but it also has some useful tools to actually sort of alter your data, transform it, to mash it up, and then put it back again. So it's a very, very powerful tool, a very good complement to Neo4j in that sense, I think.
Cool. Any other questions? Okay. I like interactive sessions personally, so and if we wanted to, I think that we could do something kind of hands-on-ish that could be fun for people.
Sure.
So, I mean, everyone could also do it on their own too, but just fun when you're.
Well, I mean, of course, if anyone wants to reach out to us at Kinoviz and wants some more information on this, or wants to demonstrate it some more, or talk a bit more about GraphXR and what it can do, then get in touch.
Yeah.
Just put your email in there too, Rob.
Fantastic. Yes.
Cool. All right. So.
Okay. I'll stop sharing now, right?
Yeah, good. So thank you. Thank you guys so much.
Thank you, Green. Thanks, everyone. Thanks, Rob.
Yep. And we'll see you guys soon. Thank you guys so much for taking the time. Really appreciate it.
My pleasure.
I hope everybody here found it valuable. And we'll see you soon. Bye.
Bye.